Okay, in problem number 40, we come to what is probably one of my favorite problems that we've worked with all year long. And that's because we're looking at linear equations and their different components, that is their slope and their y-intercept, in three different ways. We're looking at them in a graph, in a table, and in an equation. And from each of these, we need to be able to find the slope and the y-intercept, and we also have to interpret what those things mean in the context of this real-world situation. So we have three siblings, each receiving money for a holiday, and then spend it at a constant weekly rate. The graph shows sibling A's spending. The table describes sibling B's. Okay, so we'll call this A's, we'll call this B's, and the equation describes sibling C's. So this would be the equation here, and somehow we'll fit a C's in there. So what we want to do is answer the questions that are below. The variable y represents the amount of money left after X number of weeks. So what I'm going to do here is to make a little table that will help us, that will help me kind of organize this information here. And I'm going to have one column for sibling C, one for sibling B, and one for sibling A. Then I'm going to have three rows, and one of those rows, and we'll describe them in just a second. And so one row will answer the first question, how much do they have starting? So let's see, and I'll just say how much did they get. So how much did they receive? So let's look at how would we find out how much they got? We need to look at week 0. So week 0. Now, when X is 0, that is. And so for A, we can see that they received $80. For B, we can't tell how much B got. However, we can see that B's money is going down by $25 minus 25 each week. And we have the amount they had after 1 week. If we went back one more week to 0, we might have that at week 0 they had $125. Just by, instead of subtracting, we're working backwards, so we want to add that $25 on. So B had a total of $125 to start. C, in looking at the equation, how would we find out the amount that they had at week 0? We would just set X equal to 0, and we do that. When we do that, we would get Y is equal to 90. So let's rank them in order of who had the most. So 1, 2, and 3. All right, the second question asks, which sibling spends money at the fastest rate? Well, we've already seen that B is spending their money at $25 per week. All right, and if we looked at A, we'd have to find the slope there, and so we'll calculate a slope for A by labeling x1, y1, x2, y2. And so I'll say it this way, the slope for sibling A would be y2, which is 20, minus y1, which is 50, over x2, which is 4, minus x1, which is 2, and that gives me negative 30 over 2, or negative 15, which means that person A is spending $15 a week. Their money is going down by $15 a week. So on that description, I'll write how much do they spend. So A spends $15 a week, B spends $25 a week. Notice that those values are the slopes. And so if we wanted to find out how much C spends, we just look at the slope, which is negative 22.5, and that means that they're spending $22.50 per week. All right, so let's rank them. We want to see who spends at the fastest rate, so we will give the number 1 to B. 2 will go to C, and 3 will go to A. So A received the least money, and they're also spending it the most slowly. B received the most money, but they're also spending it the fastest. And C is right in the middle there. So the third question asks, when do they run out of money? So we ask the question, when do they run out? And so let's see. Now with A, we can see that it's somewhere between week 5 and week 6. So we can't yet answer that question. With B, if we were to continue on to week 5 and subtract another 25, we would see that B runs out of money at week 5. All right, in 5 weeks, we should say. All right, now for the other two, we're going to have to do some calculations. For C, and I'll write C in blue down here. Actually, since I've already started calculating A, let me go on to calculate A first. So I'm going to put this into point slope form. Y minus, pick any point, I'll use 2 and 50. Y minus 50 is equal to negative 15 times x minus 2. And we'll go ahead and work that out. Y minus 50 is equal to negative 15x plus 30. We'll add 50 to both sides, and we get y is equal to negative 15x plus 80. What have we done with these? Now we can simply set y equal to 0. When y is 0, and I'll scroll down just a little bit so that we can have room for that. When y is 0, we have negative 15x plus 80. We'll add 15x to both sides, and we get 15x is equal to 80. Dividing by 15, we get x is equal to, bring up our calculator, 80 divided by 15 is equal to 5.3. And so 5.3 repeating weeks. All right, so who was that? That was A, runs out in 5.3 weeks. B is 5 weeks. Now for C, remember that C's equation, let's go up and take a look at that. C's equation is negative 22.5x plus 90, and negative 22.5x plus 90 is equal to y. That's the amount of money they have after x weeks. We're going to set that equal to 0 to see in how many weeks they will have $0. Add the 22.5 to both sides. Let's add 22.5x to both sides. When we do, we get 22.5x is equal to 90. Divide both sides by 22.5 and bring up the calculator. And we do, we get 90 divided by 22.5, and that is exactly 4. So x is equal to 4, And so I'll scroll back up to our table here, and we will see that C runs out of money in 4 weeks. And so we have who runs out. When do they run out? We want to see who runs out first. So C is going to run out first, then B is going to run out second, and A is going to have, it should be 5.3 weeks, 5.3 repeating weeks, and so they are going to have their money for the longest, but no more than a day or two beyond B. And both of them will have at least a week beyond C's money. All right, so again, we had to look at a number of different things here. We had to find the slope in each of these different cases. One an equation, one a graph, one a table. We had to find the y-intercept in each case. We also had to find out when each one would equal 0, and we had to use different strategies to do that. We had to see that the slope really meant how fast they were spending their money. The y-intercept meant how much money they started with. And when we set y equal to 0 and solve for x, it told us when they ran out of money. So again, this is a great problem, a very interesting problem, and hope that you learn something from looking at data this way. We'll stop the video at this point, and that concludes this week's